start. Simple harmonic motion. Okay, so before we'll come to the topic simple harmonic motion, we have to understand some terminologies. Suppose you saw this amplitude. What is amplitude? Okay, now what is amplitude? First we'll come to the amplitude. Now suppose this is a bob. This position of this bob is called main position. This position is called main position. If you apply a force, then this bob will start moving and this bob will reach some distance d or some height h. So you applied force here. Because of that force, this bob will gain some acceleration and velocity. Okay, now here the kinetic energy is converting into potential energy. Why? Because bob will get some height also h. Okay, now this position is called mean position and this position is called extreme position, where bob will come at rest and it start moving toward the main position also. So from main position to extreme position, this displacement is called amplitude. Here this displacement is called amplitude. So amplitude is nothing but the displacement from main position to extreme position. Okay, here this displacement is called the amplitude. Okay, now oscillation. So oscillation, what is oscillation? Okay, now suppose the bob is moving from main position to extreme position, then again extreme to mean, and then in negative direction, mean to extreme, then extreme to mean. Now this one complete is called one oscillation. Okay, this is called one oscillation. Okay, so oscillation from mean to extreme. Getting my point? This. Now what is frequency? So we'll come to the frequency. So what is frequency? So frequency is nothing but the number of oscillation per second. Suppose this bob did this 5 times in a second. So how many oscillations this bob completed in 1 second? 5 oscillations. So frequency is nothing but the number of oscillation per unit time. So number of oscillation per unit, yeah, in 1 second. Number of oscillation in 1 second. Okay, so how many oscillations completed? Suppose 5, then in 1 second. So frequency is nothing but the 5 hertz. So frequency is nothing but the 5 hertz. Getting my point? Now here you have to remember that the velocity at this mean position will be the maximum. Velocity will be the maximum here. Now why? Because this bob has some velocity, that's why it's moving, and it will come to at rest here. It means the velocity start decreasing. So velocity is decreasing as we move from main position to extreme position. Why this so? Because acceleration is always applying toward the main position. Acceleration always toward the main position. Acceleration is always toward the main position. This side also and this side also. So because of that reason, this bob will come to at rest. After some time, this bob will come to at rest. Getting my point? Now time period. So time period is nothing but this we have two time. One we have small t and another one we have capital T. Okay, so now this capital T is the time taken from main position to extreme position. This is time period. Okay, now the small t is nothing but the whole journey time in one oscillation. Okay, now we have to show this in the form of graph. So here the bob is here now. Now suppose we put this graph. Okay, we have this graph. Here we have y and here we have x. Now this x represent here main position. This line is nothing but the main position line. Okay, now this line is nothing but the main position line. So here we have this line. Now bob is at main position. Suppose here we have bob. Right now we give some displacement. Okay, so this bob start moving in this extreme position, start toward the extreme position. So this bob will reach some height or also some displacement. Okay, now here this bob start moving. Getting my point? Now here this bob completes some displacement. So this is the maximum displacement, suppose. So again this bob start coming toward the main position. So it means this bob again start coming to the main position. Now this is nothing but the amplitude. This is nothing but the amplitude. This displacement is nothing but the amplitude. Okay. Now again this bob start moving in negative direction. So we draw the graph in negative. Okay. Again here we have maximum velocity. Maximum amplitude. So here we have maximum amplitude. Okay. So this is amplitude. Okay. And what is this? This is the displacement of this bob, or we can say displacement of particle. Okay. Now again next cycle, if you draw next cycle, then again this next cycle also goes on this. Okay, getting my point? Now the displacement the distance between two consecutive crust or trough. So this displacement between two consecutive crust or trough, this displacement is nothing but the lambda, or we can say wavelength. Wavelength is nothing but the distance. So that's why the unit of this lambda is meter. Okay, and here we have frequency is nothing but the frequency is inversely proportional to time period. Okay, so frequency is per second, or we can say hertz. Okay, that's why hertz or per second, both is correct. Okay, now we draw the graph. We understand this and we draw the graph. Now we have to convert this in the form of equations. That's why we have to solve the questions. So how we convert this in the form of equations and all. Okay, now here you saw this y is equals to a sine omega t plus kx plus some phi. Getting my point? Now here a, I told you the amplitude. Okay, now this y is nothing but the displacement of this particle. So remember, y is always less than this amplitude. It is not more than this amplitude. It is always less than this amplitude. Okay, and here we have omega. So omega is nothing but the 2 pi by t, and here we have k. So k is 2 pi by lambda. Okay, now phi. What is phi here? So phi is phase difference. Okay, now suppose the particle start moving from this main position. So from here, particle start moving from here to this extreme position. Now here we have, what is the angle here on this line? So the angle will be 0. If we saw this equation, then angle will be 0. So it means phi is here nothing but the 0. Getting my point? If the particle start moving from this position, suppose we are taking this position in consideration, and suppose this angle is some phi, or we can say pi by 6. Now the particle is moving from this side to some extreme position and come to mean position. This is mean position. Now here we have some phi. This angle is called phase difference. Getting my point? It may be anything. You want to start from here or anything else. Getting my point? Now kx, this x tells us where the particle is moving in which direction. Okay, this tells us the direction of this wave. This tells us the direction of this wave, where wave is moving. Now wave is moving in this x axis, so that's why we took here x, and the particle is moving in y direction. Okay, okay, now we'll come to this same topic. Okay, a system. Getting my point? So we have to convert this into this. Now why sine here? Because it is a sinusoidal equation, so that's why we put sine here, and here is the small t. Getting my point? Okay,